Okay, so we have a case where we want to build a chimney drain and blanket drain underneath a dam or levee here. And we want this blanket drain down here to start where the chimney drain intersects the existing ground, and we want it to end a certain distance away from where our slope hits existing ground. And let's just place a temporary dimension line here to show that. Okay, and in my case, it's just a 5 feet here. So if I step through here, we'll see that, no matter what the slope is doing here, it's following existing ground and it's stopping 5 feet away from the where the slope intersection there. So we step through and we see that it's doing what we asked it to do there. Okay, so to construct that, we're going to go to the Edit Template dialog and show how that is built there. And the chimney drain there is just a simple in condition. In this case, it's at a 200% slope going down and seeking the active surface. It has a constrained component underneath it that is just a child of that in condition, so it places that chimney drain material there. And then we have our regular four slope here on the 1-to-1 on the fill slope, and then our blanket drain is an overlay and stripping component. So when I created that, I went to add new overlay and stripping, and the properties I put in down here are I want the top and the bottom to both follow the surface, and I want the surface depth to be a negative 0.75. And what that does is it puts it up above the surface. Typically these stripping components are a stripping off the existing ground underneath, so a positive is below the surface, so we want a negative to be above the surface there. So we're going to hit, so both top and bottom are going to follow the surface at a depth of 0.75 above the surface there. And then the other trick there is on these 2 points here, I fully constrained this point, which is named CL7, to the end of the end condition there. So after this end condition solves, this component's going to move over to where that is. And same thing with this point here. If I turn on the constraints, I can see that this point is horizontally constrained to this CL5 down here, so that when this end condition solves, this point is going to adjust. And I put on the horizontal, I put a negative 5 feet there. So, wherever this solves, we're going to come 5 foot back and construct that. And then since it is an overlay and stripping component, everything in between is going to follow the surface there. So just to test that, while we're drawing it, as I move the surface up and down, I can see that overlay and stripping component um, growing to a distance that's always 5 feet back from where that slope intercepts.